first law of thermodynamics, a fundamental principle in physics, articulate the conservation of energy in the universe. The first law, total energy of isolate system remains constant over time. Energy might undergo transformation between different forms such as heat and work, but it cannot be created nor to be destroyed. The crux of the first law in its equation, where represent change in internal energy, Q is the heat added to the system and W denotes the work done by the system. This expression essentially captures the interplay between the heat and work in altering the internal energy of a system. Essentially, the first law emphasizes that while energy can be exchanged between the system and its surrounding, the net energy of the entire universe remains constant. It underscores the dynamic equilibrium between heat transfer and work done, providing a framework for understanding energy change within thermodynamics process. In ancient, the first law thermodynamics served as a guiding principle that interacts and transforms within the boundaries of a thermodynamic system.
So here I'm going to share with you our first issue, which is lack of information on spontaneity. The first law of thermodynamics, while stating that energy is conserved in a system, does not provide information about whether a particular process is spontaneous or not. Understanding the spontaneity of a process is crucial in predicting feasibility and practicality. Solution for our first issue is introduce the concept of entropy, which is a measure of the disorder or randomness in a system, along with the second law of thermodynamics. The second law helps to determine the direction of natural process by stating that in isolated system, entropy tends to increase. By incorporating discussion on entropy, educator and textbook can provide a more comprehensive understanding of the spontaneity process.
Hi and Assalamualaikum. My name is Abdul Rahman bin Alias. So I will continue about issue problem in first law thermodynamics. I will give the second issue in thermodynamics. The first law of thermodynamics does not address the reversibility of process. Many processes are not reversible, meaning that the system cannot return to its initial state without external intervention. That's the problem I found. So how to solve it? As we know, every problem has a solution. So to solve it, the concept of reversibility and irreversibility to impressing the limitation imposed by the second law of thermodynamics. Discuss how certain processes, especially in the real world, tend to be irreversible due to factors like energy dissipation, friction, and the increase in entropy. Educators and research should highlight the practical implication of irreversibility and help students understand that while the first law focuses on energy conservation, the second law introduces the constraint related to the directionality and reversibility of process. So that's how we solve it. So that's all for me. Thank you.
Assalamualaikum. My name is Safwan Asfabi Muhammad from RY31, and I want to explain about discussion of first law thermodynamics. The first issue concerning the lack of information on the subsequently emphasize the importance of considering entropy and the second law. The incorporation of this concept provides a more perspective on the feasibility and directionality of the process, enriching the application of the first law. The second issue, addressing irreversibility of the process, underscore the limitation inherent in the first law. The proposed solution involves introduction of concept of flexibility and highlighting the role of the second law in shaping the constraint of real world scenarios. That's all from me, thank you.
In conclusion, the issues relate to spontaneity and inevitability in the context of the first law of thermodynamics underscore the importance of multi-phase educational approach. By introducing concepts such as entropy and the second law, educators can enhance the understanding of thermodynamics principle, providing students with a more realistic view of energy transformation in the real world. The proposed solution offers a path toward a more comprehensive and applicable comprehension of thermodynamics, ensuring that learners are equipped to navigate the complexities of energy conservation, spontaneity, and inevitability in various physical. This approach not only deepens the understanding of fundamental principles but also prepares the individual for the practical challenge posed by thermodynamics process in diverse fields of science and engineering.